Hello, my good people. Today we're going to be looking at a phase equilibrium with something that we all know and love, and that is water. The water that we see inside of this bottle and the water that we don't see that are coexisting together are what we call in phase equilibrium. The obvious water that we can see is the liquid water, but what we cannot see inside of this container is the gaseous water. And we've already said that this is at equilibrium. Why? Because it has a cap on the top. The cap makes this a closed system. We have liquid coexisting with gas, and we all know that in order for a liquid to turn into a gas, it must take in heat. Well, today's exercise is going to be talking about LeChatliers' principle. LeChatlier is talking about something at equilibrium. A stress is applied to that system, and we observe changes. How does a system behave when a stress is placed upon a system? Well, today we're going to be looking at changing one of these variables. We have H2O, the liquid. We have heat. We have H2O, the gas. Now, there's not much I can do with a closed system. Like if, for instance, I put like some kind of tire pressure valve on the top of this, I might be able to change the H2O gas in this system, but I'm just going to go with something really easy that hopefully you'll all be able to understand. We have a microwave here. That microwave is going to help us take the H2O, and we're going to put it inside of this container called the microwave. I'm going to leave it on there for 30 seconds and try to observe what happens inside of this container. We're adding heat. Hopefully we can understand that as we add heat to this container, we will observe some changes that are going to take place. Now, your expectation, if I add more heat to this liquid, is that we should make more liquid or we should make more gas. Well, if we take a look, we actually are starting to see that we have created, we're going to start seeing a shift in this, that we're actually creating more gas molecules that'll eventually show up as condensate. There is a haze in the top of this, kind of difficult to see, but I didn't want to leave this on too long and it explode. So in other words, what we did here today, guys, in this experiment is we took the heat and we increased the heat. And by increasing the heat, we had created more we had shifted this reaction to the right, creating more H2O gas. Where did the H2O gas come from? It came from the liquid. So the liquid concentration slowly went down. So if we take a look at why I just did what I did, the heat was the initial change. The shift is this arrow right here that goes left or right. Shift will always shift away from increases, leaving us with a resultant increase in concentration of gas molecules.